tonight we're working on 5.2.2 checkup problems, which is the angles and radians topic in Algebra 2 Semester 2. So first, I guess we should probably describe what acute means, right? So acute is what from is greater than 0, less than 90, so it's between, oh my goodness, it's between 0 and 90. Obtuse is between 90 and 180. A right angle is 90. And then a reflex angle is going to be greater than 180, but less than 360. Is it 360 or 270? You guys tell me. I have no freaking idea. I want to say it's less. I think it's less than 270. Sorry. I'll double check that before I post it. Sorry. But reflex angle is between 180 and 270. So it's 0 to 90 is acute, 90 to 180 is obtuse, a right angle is 90, and then a reflex angle is 180 to 270. So we want to label these. Well, how do we know? Like, these are kind of confusing, right? So this is a unicircle. So this first quadrant, so the top right half, is where all your acute angles go. And then if you are over here, your left angles here, these are obtuse angles in the top left, and then the bottom left is your reflex angles. All right, so if I come over here and I kind of draw the rest of it, you can see that this is in that first quadrant, so this is acute. Do the same thing here, trying to find this spot. You can see how this one kind of goes into the second quadrant. So this would be obtuse. (200 degrees is greater than 180 but less than 270. This is a reflex angle. Now pi over 6, well, let's look at the unicircle. Well, pi over 6 is right here, which is a 30-degree angle, which makes it acute. (160) obtuse, right? Just know that it's right in between there. All right, arc length. Let's go ahead and change. So this is going to have a little extra steps. Is our arc length formula is equal to the radius times theta, as long as theta is in radians. So in this case, our theta has to be in radians. What the heck are radians? If you remember last section, I was telling you in the video to make sure your calculator was in degrees. Well, radians is just another way to describe an angle measurement. So we have degrees. So a good example is we have English and we have Spanish. Right? You can speak either of those two languages. So there is a word for potato in English, right? Potato, and then there's a word for potato in Spanish, which I do not know. But there's two words that describe the same thing. Radians and degrees are two ways to describe the same thing, which would be an angle measurement. So if I know arc length is equal to the radius times theta, if my radius is 1 and my theta is pi over 6, my arc length is pi over 6. It's just straight multiplication. And I know this is in radians because there's a pi. And we know that if it was degrees, it would say 70 degrees. It would have the degrees symbol there. Right, so we know this is radians. Well, and there's one more, I guess, to talk a little bit more about the arc length stuff, is if you have a radius that's equal to your arc length. All right, so if you know your radius is equal to your arc length, that means your theta is equal to 1. So if you have this formula r theta, and if you know that r and the theta are the same thing, you divide them. They cancel out and they become 1, right? If they are the same thing. And that would mean your theta would be equal to 1. I do believe that might be a question on the quiz. Anytime your radius is 1, your arc length is always going to be whatever your theta is. I think those are the 2 questions they ask you about this. All right, so now we're going to go ahead and we're going to convert degrees to radians. And how we do that is it's simple. We're simply going to multiply. We'll change colors here. Oh my goodness. Is we're going to multiply it by pi over 180. So we have 32 pi divided by 180. All right, so we have 32 pi divided by 180. I'm just going to divide it in half. I don't have a calculator, so we're kind of just going in. So that's going to be 8 pi over 45. And I don't think we can simplify this anymore. We have 8 pi over 45, so this is my radian measure. So 32 degrees is equal to 8 pi over 45. Not bad. All right, so do the same thing here. Multiply by pi over 180. I have 170 divided by pi. They both end in a 0, so I can basically just divide by 10, cancel those zeros out. So there's my radian measure, 17 pi over 18. Now to go from radians to degrees, instead of having pi over 180, it's now going to be 180 divided by pi. So I just multiply it. I can cancel my pi's, and I have 180 divided by 6. So pi over 6 is going to be 30 degrees. And I apologize for that the tractor that went by the window. The window open, they're mowing. So no, hopefully you guys don't yell at me for it. All right, so we have 3 pi times 180. So we can cancel the pi's out. So we have 3 times 180 divided by 5. All right. What I can do is I'm going to get rid of the 5 because I'm going to divide the 180 by 5. All right. So we're going to have 3 times. Well, 5 goes into 18 3 times. This is with a 30, so we have a 36. And then so 90, 102. Is that right? No, sorry, 108. My apologies. So 3 pi over 5 is 108 degrees. I just multiply. If I'm going from degrees to radians, it's pi over 180. If I'm going radians to degrees, it's 180 over pi. Now, the last thing that they talk about is they talk about coterminal. So if I draw a unicircle and I give you this angle, and we'll say this is a 45-degree angle. All right. And actually, it's just instead of me drawing it. All right, there we go. So this is the initial side. This is the terminal side. So however they do it, we have initial side and terminal side, all right? And what the questions they'll ask you is, where is the terminal side located? Is it located on the x-axis? Is it located in the first, second, third, or fourth quadrant? Is it the negative x-axis, which is on this side, right? Or the positive x-axis, which is over here? Or the positive y-axis, or the negative y-axis. All right. So there's asking where this angle goes. Sorry, I was hoping to try to get done with this before they came back around. So this terminal side is just that left side. The initial side should always be on the positive x-axis. So when they give you an angle, they're asking where this, when they're talking about where the terminal side is, we're talking about this red line. Where's that second piece that forms the angle? First quadrant, second quadrant, third quadrant, fourth quadrant, positive y-axis, negative x-axis, or negative y-axis.